Hello everyone, thanks for tuning in again to one of my videos. This video is going to be a bit different. I'm going to be talking about my latest project, the ESP32 home automation project. I mentioned in my last video that I'm going to explain a bit in more detail on how everything is set up and the code, and also NodeRed, how I set up NodeRed. I'm also going to talk about the people that helped me out in this video and where you can check them out, and also the software that I used on the Raspberry Pi and on the ESP32, the libraries that I used. So let's dive right in. So first of all, let's check out the code. So on my GitHub page, ESP32 Home Automation MQTT project, you have the libraries that are needed for the Arduino, the flow that's needed for NodeRed, and the project, Arduino project. Now, the Arduino project consists of two files, the auth.h, where you have to specify your Wi-Fi SSID, your Wi-Fi password, your Raspberry Pi's IP address, and the server username and password of the MQTT server, which is admin and password by default if you use my image. And the main project is here, ESP32 Home Automation MQTT.ino. So let's dive right in. So first of all, I include a couple of libraries, Wi-Fi, PubSub client for the MQTT, Adafruit HDU21DF for the HDU21 temperature and humidity sensor, the IR remote library, which is very, very good. Not the official library, but the one that Andreas Spies, the guy right here, I'm sure you're familiar with his work, that he modified for it to be used with the ESP32, because it was only compatible with the 8266 as far as I remember, but he modified it a bit so that it can be used with the ESP32. Arduino JSON, that's used for like parsing the JSONs that we're sending via MQTT, and we're including the auth.h file from the previous step where all our usernames and passwords are located. Now, I'm using a hardware timer, like a watchdog timer, but I mean a software timer. At the moment, I want to create like a hardware like watchdog timer, so that like even if this one fails, it's gonna restart the ESP32 whenever like a message is not sent or something like that. So when it crashes, it's gonna hardware restart it. But at the moment, I'm using this watchdog timer. So I'm just initializing the pins that are going to be used, the receiver pin, the send pin for infrared, if you saw my previous video, and I'm initializing them here. I'm initializing the HDU21D sensor, some MQTT retry attempts, Wi-Fi retry attempts, like initializing them as 0, and whenever this passes like a certain number, it automatically restarts the ESP32. Also a reset condition. Here I'm initializing the Wi-Fi client, the MQTT client, also relay GPIO pins, like which pin of the ESP32 is connected to which relay. Here I'm initializing the topics, defining the topics for weather, that's the humidity and temperature. By the way, you can see that everything starts with R1 / because that's in my example, like room 1 is just an example. Weather, the remote topic, all the relay topics, the topic for the Sony TV, because I have 2 TVs. I usually move this around from one room to another so I can like control both TVs. Panasonic topic. This Panasonic address is a hex code that needs to be sent before every code that's sent to Panasonic. Panasonic is a bit different than Sony, but you'll see it later on. This part is for the JSON parser. It just initializes a couple of things. The received callback, I'll come back to this later because I want to show you where it's actually called from. The MQTT Connect function, which is called from all the way, I think, somewhere in the loop. Yeah, it's called in the loop. So after the setup, MQTT is called. Let's just go to the setup first. Here we go, setup. So I started a serial monitor at 115.200 and connect to the Wi-Fi first. I also initialize the watchdog timer, and I set it to 14 million milliseconds, something like that. And attach an interrupt to it and enable the alarm for the watchdog timer. I'll show you how that works in a bit. I check for the Wi-Fi if it's connected, and if it's not, then try connecting again, and also do this Wi-Fi retry attempt. So, increment the Wi-Fi retry attempt, and if it's more than 5, then just restart the whole ESP32. So here I set the pin mode of all the relays to output, and I set them initially to high because the relay board that I have, that I showed you in the video, for some reason when I set it to high, then the relay is turned off, and if I set it to low, then the relay is turned on. So that's why I initially set it to high, so that all the relays are turned off. I show that I'm connected to the Wi-Fi. I show the Wi-Fi IP address, and here client, this is the MQTT client. I set the server hostname, which is set up in the auth.h file and the port, and here I set the callback function. So the callback function is whenever, let me just show you first how we connect to the MQTT. So connecting to the MQTT, we specify the client ID of the ESP32 because that has to be unique. We specify the client ID, username, password, that's all set up in the auth.h file. And here we subscribe to the topics that we need. So all the relay topics, the Sony, Panasonic, AV topic, and the weather topic. And like if the client is connected, we subscribe to them, else like do a retry of connection, and after like 5 retries, just restart the ESP32 because something is wrong. Yeah, and when the ESP32 is connected to the MQTT server, we set the callback. So the callback function listens to all the topics that we subscribe to, and whenever it receives a payload from a specific topic that it's subscribed to, it calls this function with the topic, the payload, and the length. So yeah, just print out message received from what topic, print out the payload. Need to print out the payload like for some reason like one character at a time. I don't know, I haven't been able to print it out like in one go, but this does work. And now we do a string compare of the topic and the topic we want to compare it with. So if the topic is like R1/R1. That's the topic we set up for the first relay. And the payload, so char payload 0, the first element of the payload is 1. That means turned on. We set the digital write R1, so the R1 pin to low. As I said, when we set it to low, the relay turns on. Else, set it to high. We do that for the second one as well. Here, I check whether the weather topic has been toggled. So whether I've sent some weather data, temperature, humidity, and when I have, I ping the watchdog timer so that it doesn't restart the machine. It doesn't restart the ESP32. So that's why this is here. I'm not actually listening to what I'm sending. I'm just want to hear if I'm sending anything. And when I do, I just ping the watchdog timer. I think that's how it's called, so that it doesn't restart. Here are all the relays, checking all the relay topics, blah, blah, blah. Here I check the AV topic, which is my stereo receiver. It's also, I think it's Pioneer or something like that. Yeah, it's Pioneer. So this is how I actually parse the object. I parse the payload, and if it hasn't parsed successfully, if I have a malformed JSON, I just print out failed to parse and get out of this function. And I parse it into this variable. So in the AV topic, I send a code, like root and code 1, so the first element named code 1. And I create a hex code, string to, what's it called? Unsigned long. I set the code 1, 16 bytes. I print out the hex code and I send it via the infrared diode. So IR send is from the IR remote library, and I send the hex code through that. So the TV topic Sony. So in my Sony topic, I also get like, I'm sending like 3 codes. Well, not 3 codes. I can send multiple codes in one JSON payload. So if I, for example, send 3 codes, that means press the first button, then wait a bit, press the second button, then wait a bit, and press the third button and wait a bit. That is used, for example, if I want to change the channel to a specific channel, because when I like click Fox, it's gonna send 3 codes. It's gonna send like the little dash code that shows 2 numbers, then it sends the first number, and then it sends the second number. And that's why I said like I can send up to 3 codes for Sony. So yeah, if code 1 I send the first code, wait 40 milliseconds. This is like a time that I found worked for me. So if code 2 also send the hex code, I also create the hex code like I did before from the code. I send this hex code with send Sony, also wait for 40 milliseconds. And if code 3, yeah, get a delay of 100 milliseconds, send the code, delay another 40 milliseconds. I think this is not even necessary, but okay. I left it there anyway. The Panasonic is a bit different because it has a problem with turning on the TV itself. Because when you want to turn on the TV, yeah, it's this hex code is being sent, but you can't just press it once. You need to like hold the button for it to like actually turn on. So I did like a for loop, like I sent it 10 times with a 10 millisecond delay. And send Panasonic needs like the pre-code and the hex code itself. So I send it 10 times with a 10 millisecond delay so that I can actually turn on the TV. And for the rest of the codes, I just send it 3 times, just for any case. Also with the 4004 pre-code and the hex code itself. Okay, so that's all the MQTT stuff done. So let's go to the loop. In the loop, as I said, we do the MQTT Connect. We do client.loop. And now, I also have the 1838, I believe, IR receivers connected. And it receives any code that I send via regular infrared remote control. So the receiver receives the infrared control that I sent, and it dumps the info. So the dump info decodes the results. If it's too long, then like it returns. And I encode the string and return it as a JSON. I send like what the encoding is, how many bits, and the results itself, and I publish it to the remote topic so that NodeRed can read this. At the moment I just debug it, so I just print it out. I haven't used it yet, but I have the option to, like, if I press the remote with a certain button, I can make it do something. But I'm not using that at the moment. I'm just publishing to there and just printing out the results. Now I'm going to show you how I get the temperature and humidity data. So every 5 seconds, So every 5 seconds, I read the temperature, save it to the temperature variable, read the humidity, save it to the humidity variable. I create the JSON, temperature, humidity, and publish it to the weather topic. And at the end, here is the interrupt reboot function that we're using to restart the ESP32. I just print out rebooting and restart the ESP32. And that's, I believe, most of the things explained from the code, like most of the important things, how it all works. I hope it's a bit easier for you to understand if you wanted to watch this video. But I'm gonna go now to the NodeRed setup. So in NodeRed, I have a couple of sections. First of all, let's look at the temperature and humidity parsing. So all of these nodes, TV button, room 1 weather, R1 remote, these purple nodes are all MQTT, all listening to messages from an MQTT topic. So for example, this node listens to R1/weather. It's connected to my local host server that's also like located on the Raspberry Pi. Yeah. Admin and password, all typical stuff. So when I receive a message, a payload from the topic weather, I first need to format that. So I'm using this JSON node so that I can format this message.payload to JSON. I also limit like one message per 88 seconds because I don't want to save to the database every like 5 seconds, whatever. I merely like want to have like a real-time update of the temperature and humidity in NodeRed, but I don't want to actually save it to the database. So that's why I limit the message, like limit to one message for 88 seconds, and that comes out roughly about 950 saves to the database a day, because the chart can only hold, I think, like 1000 data points in one go. So that's why I'm saving like one in every 88 seconds. And also I'm getting the outside humidity and outside temperature from darksky.net. And Dark Sky API from Dark Sky API. And the Dark Sky API has a limitation on free users, that it can do 1000 calls per day for free. So you can call the API 1000 times a day and it will be free. So that's why that's where I'm getting the outside temperature humidity data, and that's also one of the reasons why this is set up to 88 seconds, one message per 88 seconds. So as I said, I'm saving this to an SQL database. So the NodeRed that I set up, the Raspberry Pi that I set up has SQLite administration. And here you can see all the tables that are set up. Like most of them are set up automatically, but I'm using this one in particular, temperature record. I had to change the structure a bit, so I have like the device name from where it's coming, rec number, like it's an integer, I think it's auto incrementing probably. Saving the temperature, the date time, which is just saving as a current timestamp, saving the temperature outside, the humidity, and humidity outside. So this table is being used to save the actual data, and you can see like all the records. From which date, what was the humidity inside, temperature inside, humidity outside, and temperature outside wasn't set up then yet. That's why it's null. But I set it up in the meantime. As you can see, I'm getting the outside and temperature and humidity. So I'm formatting the SQL query. So I'm formatting the payload that I got from the JSON. It's basically inserting into the temperature record where device name, rec number, temperature, humidity, date, time is. I'm sending like ESP32, the temperature, the humidity, and the time, which I don't actually need to send anymore, because I had a problem before that I had a problem with the time zone offset in the Raspberry Pi, because the time zone was always like UTC, and I forgot to set up the time zone in the Diet Pi UI, well, not UI, but the console. So that's why I was always like getting weird dates coming back. Like it was always starting at like 1 a.m. and ending at like 1 a.m. next day, but the dates were good. So I alleviated that by setting the time zone. I can actually show you how I set the time zone. So if you SSH into the Diet Pi, you can run Diet Pi config. If you go to advanced options, I believe. Nope. if you go to language regional options, time zone, you can set the time zone here. Europe, I'm in Belgrade at the moment, and it's setting the time zone correctly. So this is one thing you need to do before you do anything, because your dates are going to be way out of whack. Anyway, here I'm creating the insert string of the MySQL. And sending it to the SQL database. I set up the SQL database as just a file. This is already like located on the Raspberry Pi when you set it up, so this file is already there. Now here I find the latest entry from temperature records. And when I have the latest entry, I know which record number it is. And I'm setting the global variable. This is how you set the global variable in NodeRed. Setting the global variable latest entry as the payload of whatever I got as the newest entry. And then I have like 3 options for getting the outside data. Open weather map, which is free, but it's not that secure. It's not that, it's not that accurate. Yahoo weather and dark sky HTTPS. So if you open your dark sky HTTPS, there's like your API goes here. You actually need to get an API key from dark sky and put it in there, because you can only have like 1,000 calls per day. And if you enter it here inside the HTML field, once we get back the response, we format it. And we save it. Well, we display it in the nodes that are in the UI. So we display them here. And we save it also to the SQLite database. Using this function. So we get the latest entry. And we update the temperature record, where the latest entry rec number is that we had. So first we save the latest entry with data from humidity and temperature sensor, and then we find that entry and we update the humidity and temperature outside. I know it's a bit backwards, but I haven't I haven't worked with this that much, but at the moment this does work. Maybe I'll fix it a bit in the future. But this is actually how we save to the database, temperature and humidity values. Now, for actually displaying the values in this beautiful chart, we're using the date picker component node, which is this node here, the date picker. You can select like what date you want to check the data for, and it like shows the values from that date. So whenever the date picker is changed, we format the date. It's quite complex here, but at the end we get the query where we want to pull from the database for that particular date. And when we get the query, we query the database. Again, database returns the results. We format those results so that they that they work in the chart component. So we have what date, at what time, what was the temperature, at what time was what was the humidity, at what time was the temperature outside, etc. And we push it to the chart so that the chart has the data. Here you can also set up like the x-axis, what's it gonna show, what are the colors gonna be shown like in succession, etc. When we actually save the database, when we actually save the outside temperatures, we call the getFlow query again, so that it can read the data from the database and update the chart, because you can manually update it with like this button. This was before. I can maybe even remove this, because now it's updated automatically when something is saved to the database. So let's get on to the remotes. Here are all the buttons in the UI for each remote control. So all these buttons, for example the Sony ones, are set up here, and each button just sends a payload with the name, what button is being sent, which button we want to send to the ESP32. So when, for example, the power button is sent, we set the payload as you remember, code 1 A90. This is the code for the power button. I found these codes out using the R1/remote, if you remember, topic, and logged out all the numbers. So for example, if I press the mute button on my Panasonic Remote, it's going to show up the address that I talked about earlier. That's the pre-code, the code itself, what encoding, how many bits is being sent. And that's what I use to fill up all these buttons. So yeah, when you click on the power button, it sends code A90, and then the ESP32 interprets that code, sends it through the infrared library, through the infrared diode, and turns on the TV or whatever you want. So this is how it's used for all the single buttons. And for the like channels that I want to like turn to, like in one click, I don't want to go to like press I don't know, if I want to go to like 23, I don't want to click on this, and then click on this, then click on this, because I know that's like Fox Life or whatever. I just click Fox Life and it does that for me. So these four buttons actually send code 1 B90, code 2 10, code 3 E10. So it sends all the three codes in one go, in one JSON payload, and the ESP32 can listen to that payload and set all the three codes sequentially via the IR library. For the relays, I had to do a bit of remodeling of the UI, particularly because I couldn't get one switch to be toggled from the UI or from an external source in one switch, because it was always like there was a race condition, like turning on and off at the same time. So I had to like set separate switches for on and for off. So here the relay MQTT node listens to the topic R1/R1, and sets this string desk lamp on or off based on the payload. And these two buttons actually publish to the R1/R1, which this listens to, and the ESP32 listens to, or the Arduino, whatever it's set up, and turns on or off the relays accordingly. So the relays are a bit different than in the first video, but they still work the same. You can turn them on or off. If anyone has an idea how I can set this up to be with one button, please let me know in the comments or in the Discord channel. So that's most of the NodeRed setup explained. I want to thank a couple of guys that helped me out. First of all, Peter Scargill. His script was a very big help. I just ran basically the script on my Raspberry Pi, which is somewhere, yeah, here, not sure. Yeah. Ran the script and installed like NodeRed, all the nodes, the UI, everything. It installed MQTT server, all that good stuff that's used in this project. So check it out. Check his blog out. He's a real NodeRed expert, amongst other things. I use DietPi as the operating system. It's based on Debian Linux, but it's like really dumbed down. It removed like all the unnecessary stuff that I really don't need from Raspbian. But I used version, I don't know. I used the version for Raspberry Pi 0W. Version 6, but I think I used version 4, which still had that capability to set the SSID and the password of the Wi-Fi in the text file, and you can set that up like anytime. But in the newer versions, that file is like overridden. Once the initial build is done, it's deleted. So you have to set it up like manually, going through SSH. You can't even go through SSH. You have to like insert the keyboard and to like set the wireless SSID and the password manually. So I'm gonna find probably a better solution that can be like plug and play for you guys. But at the moment, I still haven't found anything. I haven't found the time. Now, the next person I want to thank also was Andreas PS. As I said, his IR remote library hack helped me to get the IR remote library working, and he has a lot of cool videos about Raspberry Pis, ESP32s, all that good stuff, so be sure to check it out. Learned a lot from this guy. Also, Superhouse, Jonathan Oxer, has great videos about his home automation systems, and I implemented some of these things in my videos as well, so be sure to check it out. Check him out as well. His videos are very long and very educational, so you'll learn a lot from him. And that's it. I hope you enjoyed this video. If you have any other questions, please let me know, like in the comment section, or as I said, on my Discord channel. Again, if you like this video or any of my other videos, consider subscribing. That really helps me a lot and helps me build my channel. And I'll see you in the next one, guys, I hope. Cheers.